Solve the following systems of inequalities graphically. So x squared plus y squared is less than or equal to 25. 3x minus 5y is greater than negative 15. Okay, so starting off, we're going to graph these individual functions. So the top equation I recognize as a circle with radius 5. So I'm going to do my best to draw a nice circle radius 5 on my axis. You do want to make sure you're choosing either a dashed line or a solid line. In this case, because it's greater than or equal to, we would use a solid line. So I'm going to draw the nicest circle I can. Here we go. Now, I do need to shade this. So I'm either going to shade basically the inside of the circle or the outside of the circle. And so I just need to choose a point on the plane, and the easiest thing to generally use is the origin. So if I test the origin for the first, it would be 0 squared plus 0 squared is less than or equal to 25. Or 0 is less than or equal to 25, which is true. And because that's true, that's the part of the graph that I shade, which is the inside of this circle, because the inside contains the origin. Now, the next thing that I need to do is repeat this process, but for that line that's provided. And I'm going to switch to a different color here. So to graph this line, I'm going to solve it for y, because it's always easier that way. So 3x minus 5y is greater than negative 15. So negative 5y is greater than negative 3x minus 15. And if I divide both sides by negative 5, I get y is less than 3/5 of x plus 3. Remember, I turned this sign around because I divided through by a negative number. So 3/5 x plus 3. So I have a y-intercept of 3 and a slope of 3/5, which means I would go up 3, 2, 3, and to the right 5. 1, 2, 3, 4, 5. There's my next point. Up 3 over 1, 2, 3, 4, 5. Or I could go down 3 and back 5. So right there, so down 3. Missed my point there, sorry. 1, 2, 3, 4, 5. That looks good. Okay, once you have enough points to, accurately draw your line, just draw it in. In this case, make sure to use a dashed line because the original graph just had a greater than instead of a greater than or equal to. So I'm going to draw a dashed line for this line. Here we go. Now, I need to either shade above the line or below the line. And it really comes down to testing the origin again. So if I plug the origin into this equation, it would be 3 times 0, which is 0, minus 5 times 0, which is 0, is greater than negative 15. So 0 is greater than negative 15. And that is true. And because that's true, that's the side of the line that I shade. So everything on this side of the line is a solution to the line. Now, where these intersect, that's where the solution to the system is. So the solution to the system, is this region here in red that I'll sketch out. And what a mess I have on the board here, but that is the solution region.